Welcome, math students. In this video, I'll be looking at linear equations and looking at several different techniques that we can use to construct linear equations. First task is to state the equation for the following lines. We have here a line drawn in a thick red color that is parallel to the x-axis and crosses the y equals 8, or it has an intercept of y equals 8. Quite simply, this has the equation of y equals 8. Likewise, on the right-hand side, we have here a line that's parallel to the x-axis, crosses at the y equals minus 4. So the equation for that line is y equals minus 4. In both of these graphs, we have a line that is completely flat. This represents a gradient of 0. The second task we have is to state the equations for these two vertical lines. This is just the opposite of our previous example. Here, we have a line on the left-hand side that's parallel to the y-axis. So it represents an equation not of y equals something, but rather x equals, and it crosses at the point 2. So this first equation is x equals 2. On the right hand side, we have another equation where the line is parallel to the y-axis, and it crosses the x-axis at minus 6. So this equation is y equals minus 6. In both cases, we have a line that is completely vertical. This gradient is classified as undefined. Our next task is to state the equation given the gradient and the y-intercept. We'll look at our first column where the gradient equals 2 and the y-intercept equals 4. Now we use the letter m to represent the gradient and the letter c to represent the y-intercept. And here's our general equation for a straight line relationship. Y equals mx plus c. Let's sub in where we have m, we're going to sub in the 2. And where we have c, we're going to substitute in the value 4. So we end up with y equals 2x plus 4. And you can see color-wise, the 2 replaces the m and the 4 replaces the c. So the equation with a gradient of 2 and a y-intercept of 4 is y equals 2x plus 4. And this is what it looks like. Okay, you can see here we've got a rise of 4 and a run of 2. That gives us a gradient of 2, as we have here. And also it intercepts the y-axis. So the y-intercept is at 4. And that is our y-intercept of 4. That's what that particular equation looks like. Our second example looks at the gradient of minus 3 and a y-intercept of minus 2. Here's our general rule for a linear equation. Let's substitute in the m value. The blue is minus 3 goes in, and the red for c is minus 2. Let's simplify that. That tells us a gradient of minus 3 and a y-intercept of minus 2 gives us the equation, the linear equation of y equals minus 3x take 2, because adding the negative 2 simplifies to take 2. As an equation here, you see we've got a negative gradient, hits the point here at minus 2, the y-intercept of minus 2 as our equation has, and the rise over run here is a negative 3. Finally, we have a gradient of 2/3 and a y-intercept of 5. Here's our general equation for a linear equation. We sub our values in. The gradient, m, equals 2 on 3, and the y-intercept is 5. Gives us a linear equation of y equals 2/3 x plus 5. And here it is graphed. We have a gradient here, a rise of 2 over a run of 3, 2 over 3, and a y-intercept of 5. That's what the equation looks like graphically. Next task, let's consider the equation of a line formed between the following 2 points. So point 1 is 2, 3, and point 2 is 8, 6. Now these are just Cartesian coordinates. So the first point is always an x. This is the x value of point 1. So we label it x1, number 2. And this is the y value of point 1. So this is labeled y1, and its value is 3. Likewise, point 2 has got an x value, x2, its value is 8, and has a y value, y of point 2, its value is 6. So let's first of all do step number 1 in finding the gradient. Our equation is m equals y2 take y1 over x2 take x1. Let's substitute these values in. So to find the gradient between 2 points, 6 replaces y2, y1 is number 3, 3 goes in the spot for y1, x2 was 8, it gets replaced by 8, and x1 is 2, so 2 is substituted in, which means our expression looks like this. 6 take 3 over 8 take 2. And 6 take 3 is 3, 8 take 2 is 6, 3 over 6 can be simplified to a half. So these 2 points have a gradient of positive 1/2. Finally, let's have a look at calculating the actual equation. To do this, we're going to need y1, there's y1. We're going to need m, there's m, and we're going to need x1, there's x1. This y and x has no relevance in terms of substitution. So let's substitute those values in. So y take away y1 is 3, so y take 3 is equal to m, the gradient, which is a half, in brackets x take x1 was 2, and we sub the value of 2 in. Okay, all our numbers are substituted in. Let's now expand the right-hand side bracket. So that half is multiplying the x, and it's multiplying the 2. So we're going to have half of x, and half of 2 is 1, and there's also a take in there. So we're going to end up on the right-hand side having a half x, take away a half of 2 is 1. And finally, to get y by itself, so it looks like the normal y equals mx plus c, we need to get rid of this take 3 by adding 3 to both sides. So we end up with y equals a half x and minus 1 plus 3 to get rid of it. It gives us plus 2. So our equation is y equals a half x plus 2. Here it is visually. We've got our points 2, 3 and a 0.86. Our gradient rise over run is 0.5 and our y-intercept is 2, exactly as our equation predicts. Our second example using 2 points. This time we've got an x1 of 2, a y1 of 4, an x2 of 8, and a y2 of 10. Let's first of all find the gradient between these 2 points. Here's our equation. Let's sub in our values. y2 is a 10, y1 is a 4. They get subbed in on the top. Then on the bottom, x2 is an 8, goes in first. Take away x1 is a 2, goes in second. 10 take 4 is 6, 8 take 2 is 6. This gives us a gradient of 1. Let's now substitute these values in to find the equation. Here's our general expression, and we're going to sub in y1 is the number 4, that gets replaced. M is the number 1, that gets replaced. And x1 is the number 2, that gets replaced or substituted in. We can now expand our right-hand side bracket. 1 times this bracket just gives us what's in the bracket. So we have now y take 4 equals x take 2. Now to get rid of this take 4 and leave us with y equals in the normal format, to get rid of take 4, let's do the reverse, and we're going to add 4 to both sides. So that cancels out my left-hand side. Minus 2 plus 4 gives me plus 2. So my equation is y equals x plus 2. Let's look at this graphically. Here's our first point, 2, 4. Here's our second point, 8, 10. The gradient of this is 1, as we predict. By the way, 1x is simplified to be just simply x. So we've got a gradient of 1, and we've got a y-intercept of plus 2. It all matches perfectly. Finally, our third and final example of finding the equation of a line between 2 points. We've got an x1 value of negative 2 and a y1 value of 8. Point 2 has got an x2 value of 6 and a y2 value of 4. Let's find the gradient for step number 1. Here's our equation. Let's substitute in the values. y2 is 4, y1 is 8, x2 is 6, x1 is minus 2. So 4 take 8 is our substitution, and 6 take negative 2 is our substitution. 4 take 8 gives me negative 4. 6 take a negative 2 is effectively the same as 6 plus 2. The minus of a negative number is the same as an addition. So 6 plus 2 is 8. So that it gives us a gradient of negative 4 on 8, or negative 1/2. Finally, let's find the equation between these 2 points. Here's our general formula. Let's sub in our y1 value of 8, our m, our gradient of minus 1/2, and our x1 value of minus 2. So first of all, let's simplify what's happening in the brackets here. If I've got x take away negative 2, that's the same as x plus 2. Now I want to expand my brackets. Negative 1/2 of x gives me a negative 1/2 x, and negative 1/2 of 2. Half of 2 is 1, and negative makes it minus 1. So we're almost there. Let's get rid of our minus 8 by plussing 8 to both sides. That will give me a y equals minus 1/2 x, and the minus 1 plus 8 becomes plus 7. Let's graph that. We have here our 2 points, negative 2, 8, and 6, 4, the gradient of which is minus 1/2. So there's our minus 1/2. And the y-intercept is between 6 and 8, right in the middle, that's plus 7. Again, this graphically supports the evidence of our equation that we just calculated. Thank you for watching this video. I hope it's explained 2 or 3 different techniques that allows you to calculate the equation of a linear relationship. If you've enjoyed this or learnt something, please like, share, comment, and subscribe. And as always, thanks for watching.